Hello children, welcome to mathematics online classes. In today's video from mathematics subject, quadratic equations topic we are going to continue. In our previous videos children, we have completed some of the concepts mentioned here. 1 minute. We have completed basic concept and how to find value of quadratic polynomial, zeros, quadratic equation and its roots, solving by factorization, solving by completing the square method, solving the quadratic equation by using quadratic formula, and about nature and character of roots of quadratic equation. All these topics we have finished. So now in this video we are going to learn the concept of 1 minute children, sum and product of the roots, and to construct a quadratic equation whose roots are given. So regarding these two concepts we are going to learn today. So one is regarding sum and product of the roots, another one is how to construct a quadratic equation whose roots are given. These two are the topics for today. Here children. So we know that the general form of quadratic equation is ax square plus bx plus c equal to 0, which will be having at most two roots. At most two roots. Suppose one root if we consider it as alpha, another one if we consider it as beta. The quadratic equation will be having roots in the form of minus b plus or minus root of b square minus 4ac by 2a. If you consider a positive value, then we can take it as alpha. If you consider negative symbol here, then we can take it as beta. So like this, the quadratic equation which is in the form of ax square plus bx plus c equal to 0 will be having two roots, alpha and beta, in this form. Alpha and beta in this form. So now, if you want to find out the sum of the roots, already we know the value of alpha, already we know the value of beta. By adding both the values, we can find out the form of, or we can find out the general form of sum of the roots of quadratic equation, which is in the form of ax square plus bx plus 0. Instead of adding alpha and beta every time, we will make it as a formula, so that we can apply this directly whenever there is a need of sum of roots. So if you want to add alpha plus beta, let's keep alpha value first, then let's keep beta value first. Here the denominator is 2a, here also denominator is 2a. So common denominator is 2a. 2a one time, 2a. With 1 we have to multiply the numerator, so value does not change. Minus b plus root of b square minus 4ac will come. Next 2a one time, 2a. With 1 we have to multiply the numerator, again value does not change. Plus into minus, minus b, plus into minus, minus root of b square minus 4ac. Like this, if we take the LCM, this we are getting. Here b square minus 4ac, same value, but one is positive, one is negative. We can cancel them. Then minus b will become minus 2b by we are having 2a. Again 2 gets cancelled. We will be having minus b by a as the result. So the shortcut for sum of the roots, if the equation is in the form of ax square plus bx plus c equal to 0, if its two roots are alpha and beta, then what is their sum means we can directly write their sum as alpha plus beta equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. Like that. So directly we can remember this as a formula. Suppose if you want to find product of roots, So let's multiply alpha and beta. Let's keep alpha value in brackets. Let's keep beta value in brackets. If we multiply them, so minus b into minus b, or it is in the form of minus b minus root of b square minus 4ac. Suppose it is x. If it is y, it is in the form of x minus y and x minus y and 1 minute children, x minus y and minus b minus root of b square minus 4ac, means it is in the form of plus. It is in the form of x plus y. So the numerator part, if you observe carefully, so one is in the form of x minus y, another one is in the form of x plus y. If you multiply x minus y and x plus y, the result will be equal to x square minus y square. So in the place of x, as we have minus b here, in the place of x, as we have minus b here, so what we can do? Minus b whole square minus root of b square minus 4ac, because in the place of y, we have root of b square minus 4ac whole square. We can write the numerator like that, and denominator part 2a into 2a. As we are multiplying here, we have to multiply the denominators. 2 into 2, 4, a into a square. 4a square will be the denominator. Now, minus b whole square will become b square. Here, square root and square gets cancelled. We will be having minus of b square minus 4ac. But if we remove the bracket, because of minus, the symbols will change. Plus b square will become minus b square. Minus 4ac will become plus 4ac. b square gets cancelled. 4ac by 4a square will be remaining. 4 gets cancelled. a gets cancelled. Sorry, 1a gets cancelled. In denominator part, 1a will be remaining. In numerator, c will be remaining. So c by a is the answer. So the product of two roots of quadratic equation, which is in the form of ax square plus bx plus c equal to 0, will be equal to c by a. Alpha into beta equal to c by a, where c is the constant, and a is the coefficient of x square term. So, if alpha and beta are the roots of quadratic equation, so then alpha plus beta equals to minus b by a. We can directly remember this, which means minus coefficient of x by coefficient of x square. That is the formula for sum of roots. And product of roots formula, alpha beta equal to c by a, where c is the constant term, a is the coefficient of x square term. So you have to remember these two formulas carefully, children. So then only we can solve the quadratic equations directly. Next one. So another concept for today is to construct a quadratic equation whose roots are given. For a quadratic equation, ax square plus bx plus z equal to 0. Suppose if alpha plus beta are the roots, here they have not given the equation. They have not given, but simply they have given the roots. Now the question is, provided the roots, if roots are provided, how to construct a quadratic equation based upon the roots, or based upon the sum of the roots, or based upon the product of the roots, how to construct the quadratic equation. That we are going to learn now. So the general form of quadratic equation is ax square plus bx plus c equal to 0. This is one form. Or we have also another form, which is x square minus sum of roots into x plus product of roots equal to 0. Equal to 0. This is the another form based on roots for a quadratic equation. Means to get a quadratic equation with given roots alpha and beta, first we have to find their sum alpha plus beta, then we have to find their product alpha beta, then using this general form x square minus sum of roots alpha plus beta x plus product of roots alpha beta, we can get the required quadratic equation. So let's see some examples here. So here, example 16. For each quadratic equation given below, find the sum of the roots and product of the roots. Just we have to find the sum of the roots and product of the roots. So construction part they have not asked in this example. Just we have to find sum of roots and product of roots. So these three are the equations. Let's see one by one. First one. So the given equation is x square plus 3x minus 6 equal to 0. If we compare this with the general form, in the place of a, x square coefficient is 1. So a value is 1. In the place of b, we have 3. In the place of c, we have minus 6. Now, sum of the roots alpha plus beta equal to, we have the formula minus b by a. So minus b value is 3, a value is 1 children, not 2 here, not 2 here children, it's 1, a value is 1. So 1 children. So minus 3 by 1 equal to minus 3. Minus 3 is the answer. And product of the roots means alpha beta means we have the formula c by a, where c is the constant which is minus 6. A is the coefficient of x square which is 1. Minus 6 by 1 equal to minus 6. Like that, in very easy manner we can find the sum of roots and product of the roots, but the only thing is you have to remember the formula, then only it is simple, otherwise it is difficult. Next one, second equation. So the equation is 2x square plus 5 root 3x plus 6 equal to 0. If we compare it with general form, in the place of a we have 2, in the place of b we have 5 root 3, in the place of c we have 6. Sum of roots alpha plus beta equal to minus b by a minus 5 root 3 by 2, because b value is 5 root 3, a value is 2, just we have to substitute the values, and product of the roots alpha beta equal to c by a, c value is 6, a value is 2, 6 by 2 is nothing but 3. Like this we can find. Next, third one children, in the same model. Here solution is there. Later you can do it as a homework. Next children, example 17. Example 17. So construct a quadratic equation whose roots are given below. Whose roots are given below. Here they have given the roots in 3 questions. They have given alpha beta values. We have to construct the roots first by finding their sum and product. By finding their sum and product, we have to find the equation of the quadratic equation. So I will do the third one children. First and second complete solutions are there. You can observe. You can observe later. So directly I am doing the third one. So the roots are alpha is 2 plus root 5 by 2. Beta is 2 minus root 5 by 2. So for finding the quadratic equation, first we have to find sum of the roots and product of the roots. So let's find sum of the roots first. Alpha plus beta, 2 plus root 5 by 2 plus 2 minus root 5 by 2. 2 is the common denominator. LCM will be 2. 2, 1 is 2. 1 into numerator, same numerator will come. So same numerator will come. Again, 2 into 1 equal to 2. 1 into 2 numerator, same numerator will come here also. Here root 5 minus root 5 gets cancelled. 2 plus 2 equal to 4 by 2, which is equal to 2. So sum of the roots, alpha plus beta value, we have got 2. Now product of roots, alpha beta, 2 plus root 5 by 2 into 2 minus root 5 by 2. It is in the form of x plus y into x minus y, which is equal to x square minus y square. In the place of x we have 2 square. In the place of y we have root 5 whole square, where 2 square equals to 4. Root 5 whole square means square roots gets cancelled, 5. So 4 minus 5 by 2 into 2 equals to 4. 4 minus 5 equal to minus 1. So alpha beta value equals to minus 1 by 4. Minus 1 by 4. So now we have got alpha beta and alpha plus beta, both the values. Now the required quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. X square minus, in the sum of the roots place we have to keep 2. In the product of roots place we have to keep minus 1 by 4, which is equal to 0. The LCM is 4. The LCM is 4. So 4 into x square, 4x square. 4 into 2x minus 8x. 4, 1 is 4. 1 into minus 1 equals to 0. So 4x square minus 8x minus 1. This 4 will go towards right hand side. 4 into 0 will become 0. So this is the quadratic equation which can be formed with the roots 2 plus root 5 by 2 and 2 minus root 5 by 2. Okay, children? Like this 1 and 2. 1 and 2, they are simple questions. You can solve them. Next question number 18. So here question is, if A and C are such that the quadratic equation ax square, the quadratic equation ax square minus 5x plus 3 equal to 0 has 10 as the sum, 10 as the sum of roots and also as the product of roots. Find A and C. Find A and C. Here children, this is not 3 actually, this is C. The given equation is ax square minus 5x plus C. We have a quadratic equation ax square minus 5x plus C such that if it has roots alpha and beta, their sum is 10 and their product is 10. Their product is 10. Both are equal to 10. Then we have to find the value of A and C. So let's find sum of roots first. Sum of roots formula minus b by a means minus coefficient of x by coefficient of x square, where coefficient of x is minus 5. So we will get minus of minus 5 by coefficient of x square is a. Minus into minus, it will become plus 5 by a. We are getting 5 by a as sum of the roots. So product of roots is, the formula is c by a, means constant term by coefficient of x square. Constant term here is c. X square coefficient is a. C by a. We are getting 5 by a and c by a. But as per the question, sum of the roots is 10. So 5 by a is 10. So 10a equal to 5 or a equal to 5 by 10. or a equal to 1 by 2. We are getting a value. And they have also given that product of roots also 10. Then c by a equal to 10, c equal to 10a, c equal to 10 into, in the place of a we can keep 1 by 2, c equal to 5. So a value 1 by 2, c value 5, these two values we have got. So if they have given the sum of roots value and product of roots value, unknown terms in the equation also we can find them out. Next children, example 19. Example 19. So here, if one of the roots of quadratic equation, this is the equation, is to find the value of p and find the value of other roots. So they have given one equation and they are telling that one root is 2. Means x value, one value of x is 2. Then what is the other root, and find the value of p also. So this is the given equation. As they have given the root means, what does root mean? Root mean it will satisfy the equation. Means in the place of x, suppose if the equation is f of x, in the place of x if you keep 2, then the value will become 0. That is the meaning of root. Means in the place of x, if you keep 2 into 2 square, p into 2 plus 4, then it should become equal to 0. 2 into 2 square equal to 8, p into 2 equal to 2p, plus 4 equal to 0, 8 plus 4 equal to 12, 12 will come this side, it will become minus 12, 2p equal to minus 12, p equal to minus 6. We have got p value. If we substitute p value in the equation, we will get this equation. Because here coefficient of x square is 2, if we divide the entire term by 2, entire equation by 2, then what happens? We will be having the equation x square minus 3x plus 2 equal to 0. Now we can take factors, we can take common, and we can find the values of x. In that, x equal to 2 we are getting, x equal to 1 we are getting. Already they have given x equal to 2 value. So the other root is x equal to 1. So that is the method children. Next children, example 20. In the following, find the values of p so that the given equation has equal roots. These two equations, they are having equal roots children. So then find the value of p. We have to find the value of p. We already know the condition that quadratic equation will be having equal roots when the discriminant value equal to 0. When the discriminant value is equal to 0, then only it will be having the equal roots. Let's see the second one children. First one you can do it as a homework. Second one I am explaining. So this is the equation. If we compare with quadratic equation, in the place of a we have 2p, in the place of b we have minus 8, in the place of c we have p. But they have given roots are equal, so discriminant to be taken as 0. So minus 8 whole square minus 4 into 2p into p, just we have to substitute the values, equal to 0. Minus 8 whole square means 64. 4 into 2, 8. P into p, p square equal to 0. If 64 comes towards right hand side, minus 8p square equal to minus 64. Minus minus gets cancelled. P square equal to 64 can be written as plus or minus 8 whole square. P square equal to plus or minus 8 whole square. Like this we can write. Square square gets cancelled. P equal to plus or minus root 8 we will get. where root 8 can be written as root 4 into 2, where square root of 4 is 2. So root 8 can be written as 2 root 2. So the answer is plus or minus 2 root 2. P value is plus or minus 2 root 2. Next one, example 21. If alpha and beta are the roots of quadratic equation, this equation, then find the values of alpha square plus beta square, alpha cube plus beta cube, and alpha by beta plus beta by alpha. Alpha by beta plus beta by alpha. This we have to find out. So first and do. One minute, children. First and two, you can do them as homework, children. You can take a screenshot and you can do them as homework. Third one, I will be explaining now. Here also, you can take the first one screenshot, children. Later, you can do them as homework. Here also, this 1 and 2. This 1 and this 2. These are all homework, children. Now, in this third one. So, we have to find the value of alpha by beta plus beta by alpha. First, we have to simplify this. If we take the LCM is alpha beta. So, beta into alpha, alpha beta, beta into alpha, alpha beta. With the alpha, we have to multiply numerator. It will become alpha square. Next, alpha into beta, alpha beta. With beta, we have to multiply numerator. It will become beta square. So, we are getting alpha square plus beta square by alpha beta. In previous examples, okay. Okay, alpha square plus beta square. One minute, children. 1 minute. There is a problem with pen. Alpha square plus beta square means it can be written as alpha plus beta whole square minus 2 alpha beta. It can be written as alpha plus beta whole square minus 2 alpha beta, where alpha plus beta already we know it is minus b by 2a whole square minus alpha beta value c by a. C by a means minus b square minus b whole square means it will become b square, 2a whole square, 4a square minus 2c by a. This we are having. LCM is 4a square into a, 4a square. In the numerator part, we will be having b square minus here a is there, a into 4a, 4a square, a into 4a, 4a square. Sorry children, here b by a, not b by e. To a, b by a means b square by a square. A square, a, the LCM is only a square. So here a square is there, numerator part b square will come. Here a into a square, a into 2c minus 2ac will come. So the alpha square plus beta square value, if we simplify, it will be equal to b square minus 2ac by a square, and alpha beta value c by a. C by a. Now this c by a, if we take to numerator, it will become its reciprocal a by c, where 1a gets cancelled, only 1a will remain. A into c, ac or ca we can write. This is the numerator part. This is the numerator part. 1 minute, children. Okay, children, that's all for today. Thank you for watching our video, children. Have a good day.